You're listening to LeadAI.dev, your daily updates on AI development. Today's topic is on-device ASR models hit CPU-only streaming breakthrough in 2024. Here's a quick overview. Breakthrough research demonstrates how compact ASR models can deliver high-accuracy speech recognition on CPU-only edge devices without GPU acceleration requirements. Now, let's ask our analyst about these developments. What's new? CPU-only ASR models achieve production-ready accuracy?
Researchers have achieved a significant breakthrough in on-device automatic speech recognition by developing compact models that deliver high accuracy while running entirely on CPU without GPU acceleration. The comprehensive study published on ArcSiv systematically evaluates state-of-the-art ASR architectures across encoder-decoder transducer and LLM-based paradigms, testing them in batch, chunked, and streaming inference modes. This research addresses the critical challenge of deploying speech recognition on edge devices where GPU resources are unavailable or cost prohibitive, opening new possibilities for real-time voice applications in constrained environments. The study focuses on jointly optimizing three critical factors: accuracy, latency, and memory footprint. Traditional ASR deployments have relied heavily on GPU acceleration to achieve acceptable performance, creating barriers for edge deployment scenarios. The researchers conducted systematic empirical evaluations to identify architectural patterns and optimization techniques that enable high-quality speech recognition within the constraints of CPU-only inference. Their methodology encompasses comprehensive benchmarking across different inference modes, providing developers with concrete guidance for selecting appropriate architectures based on specific deployment requirements. Previous on-device ASR solutions typically required significant accuracy trade-offs when operating without GPU acceleration, often resulting in word error rates that made them unsuitable for production applications. This new research demonstrates that carefully designed compact models can achieve competitive accuracy levels while maintaining low latency inference on standard CPU hardware. The findings represent a shift from the prevailing assumption that high-quality ASR necessarily requires GPU resources, potentially democratizing access to advanced speech recognition capabilities across a broader range of devices and applications. Systematic evaluation of encoder-decoder, transducer, and LLM-based ASR architectures for CPU-only deployment, comprehensive benchmarking across batch, chunked, and streaming inference modes with latency measurements, joint optimization framework balancing accuracy, latency, and memory footprint for edge deployment empirical validation demonstrating production-ready accuracy levels without GPU acceleration requirements, architecture-specific recommendations for different deployment scenarios, and performance constraints.
Thank you for that analysis. Let's move on. Who benefits from CPU-only ASR deployment capabilities?
IoT device manufacturers and embedded systems developers represent the primary beneficiaries of these CPU-only ASR advances. Companies building smart home devices, automotive infotainment systems, and industrial control interfaces can now integrate high-quality speech recognition without the cost and power consumption associated with GPU hardware. Edge computing platforms in retail, healthcare, and manufacturing environments gain access to real-time voice interfaces that operate within strict latency and privacy requirements. Mobile app developers working on voice-enabled applications can reduce infrastructure costs by processing speech locally rather than relying on cloud-based ASR services. Enterprise teams developing private cloud solutions and on-premises voice applications benefit significantly from these deployment options. Organizations in regulated industries like healthcare and finance can maintain data sovereignty while providing voice interfaces to users. DevOps teams managing containerized applications can deploy ASR capabilities without GPU-enabled infrastructure, simplifying deployment pipelines and reducing operational complexity. Research institutions and academic labs with limited GPU resources can conduct speech recognition experiments using standard CPU hardware, lowering barriers to entry for ASR research projects. Teams should consider waiting if their applications already achieve acceptable performance with existing GPU-accelerated solutions or cloud-based ASR services. Organizations with abundant GPU resources and no edge deployment requirements may not see immediate benefits from CPU-only optimizations. Applications requiring the absolute highest accuracy levels might still benefit from GPU acceleration, particularly for challenging acoustic environments or specialized vocabularies. Companies with established ASR pipelines should evaluate whether migration costs justify the benefits of CPU-only deployment. IoT manufacturers seeking cost-effective voice interfaces for resource-constrained devices, edge computing platforms requiring real-time speech processing with privacy constraints, enterprise teams building on-premises voice applications without GPU infrastructure, mobile developers reducing cloud dependency and infrastructure costs for voice features, research institutions conducting ASR experiments with limited GPU access.
Great insight, really helpful context. How to get started. Implementing CPU-only ASR step by step.
Begin implementation by evaluating your specific deployment constraints, including target latency requirements, available CPU resources, and accuracy thresholds. Assess whether your application needs batch processing for recorded audio, chunked processing for near real-time scenarios, or streaming inference for live conversations. Download the research paper and benchmark data to understand which architectural approaches align with your performance requirements. Establish baseline measurements using existing ASR solutions to quantify improvement targets and validate deployment success. Select the appropriate ASR architecture based on your inference mode requirements. For streaming applications with strict latency constraints, prioritize transducer-based models that support incremental decoding. Encoder-decoder architectures work well for batch processing scenarios where latency is less critical. LLM-based approaches offer flexibility but require careful memory management on CPU-only systems. Configure your development environment with CPU optimization libraries like Intel M, K, LD, N, or OpenBlaze to maximize inference performance. Implement model quantization techniques to reduce memory footprint while maintaining accuracy levels. Validate deployment performance through systematic testing across representative audio samples and acoustic conditions. Measure actual latency, memory usage, and accuracy metrics on target hardware to ensure requirements are met. Implement fallback mechanisms for handling audio quality variations and out-of-vocabulary scenarios. Set up monitoring and logging systems to track model performance in production environments. Consider implementing adaptive quality controls that adjust processing parameters based on available CPU resources and real-time performance metrics. Evaluate deployment constraints. Latency targets, CPU resources, and accuracy requirements select architecture based on inference mode. Streaming transducer, batch encoder-decoder, or hybrid approaches configure CPU optimization libraries Intel M, K, LD, NN, OpenBlaze, and implement model quantization, validate performance on target hardware with representative audio samples and acoustic conditions, implement monitoring systems, and adaptive quality controls for production deployment.
That's a very interesting point. Tell us about competitive context. How CPU-only ASR changes the landscape.
This research positions CPU-only ASR as a viable alternative to cloud-based services like Google Speech to Text, Amazon Transcribe, and Azure Speech Services. While cloud solutions offer superior accuracy for challenging scenarios, CPU-only deployment eliminates network latency, reduces ongoing costs, and addresses privacy concerns. Open source frameworks like OpenAI Whisper and Mozilla DeepSpeech have provided CPU compatibility, but often with significant accuracy trade-offs compared to their GPU-accelerated versions. The systematic optimization approach demonstrated in this research bridges the performance gap while maintaining deployment simplicity. Compared to specialized ASR hardware solutions and dedicated neural processing units, as CPU-only models offer greater deployment flexibility and lower hardware costs. Companies like Nuance and Speechmatics have focused on optimized cloud deployments, while this research enables similar capabilities on standard computing hardware. The approach creates competitive advantages for applications requiring real-time processing without internet connectivity, such as automotive systems, industrial automation, and privacy-sensitive healthcare applications. Edge AI platforms gain new capabilities without requiring specialized silicon or GPU acceleration. Current limitations include reduced accuracy for noisy environments compared to large-scale cloud models and potential performance degradation on older CPU architectures. Multi-language support may require separate model deployments, increasing memory requirements. Real-time streaming performance depends heavily on CPU specifications and concurrent system load. Applications requiring the highest possible accuracy or supporting dozens of languages simultaneously may still benefit from GPU acceleration or cloud-based solutions with larger model capacities. Eliminates network latency and ongoing costs compared to cloud-based ASR services, bridges performance gap between CPU and GPU implementations through systematic optimization, enables privacy-sensitive applications without internet connectivity requirements, provides deployment flexibility without specialized hardware or NPU requirements.
Good analysis. Let's continue. What's next? Future implications for Edge ASR development.
The research establishes a foundation for next-generation Edge ASR development, with future work likely focusing on multi-language support and domain-specific optimizations. Researchers are expected to extend these techniques to support code-switching scenarios and specialized vocabularies for medical, legal, and technical applications. Integration with emerging CPU architectures featuring enhanced AI acceleration capabilities will further improve performance without requiring dedicated GPU resources. The methodology provides a template for optimizing other speech and audio processing models for edge deployment. Integration opportunities emerge across the broader AI ecosystem, particularly with large language models and multimodal applications. GPU-only ASR capabilities enable voice interfaces for local AI assistants and conversational applications without cloud dependencies. The approach aligns with growing emphasis on privacy-preserving AI and federated learning scenarios where data processing must remain on device. Mobile and embedded platforms gain new possibilities for sophisticated voice interfaces without compromising battery life or requiring network connectivity. Long-term implications suggest a democratization of high-quality speech recognition capabilities across diverse hardware platforms and deployment scenarios. The research methodology may influence development of other resource-constrained AI applications, from computer vision to natural language processing. As CPU performance continues improving and specialized instruction sets for AI workloads become more common, the gap between CPU and GPU performance for inference tasks will likely narrow further. This trend positions CPU-only deployment as increasingly viable for production applications requiring real-time AI capabilities. Extension to multi-language support and domain-specific vocabulary optimization integration with emerging CPU architectures featuring enhanced AI acceleration enablement of privacy-preserving voice interfaces for local AI assistants, template methodology for optimizing other speech and audio processing models.
Great analysis. So, what are the key takeaways from all of this?
CPU-only ASR models can achieve production-ready accuracy without GPU acceleration through systematic architecture optimization. Streaming inference modes enable real-time voice applications on edge devices with standard CPU hardware. Joint optimization of accuracy, latency, and memory footprint makes high-quality ASR accessible for resource-constrained deployments. Comprehensive benchmarking across inference modes provides concrete guidance for selecting appropriate architectures based on deployment requirements.
And what market signals should our listeners watch for?
Edge AI infrastructure democratization. The breakthrough in CPU-only ASR represents a broader trend toward democratizing AI capabilities on standard hardware. This development reduces barriers to entry for companies seeking to deploy voice interfaces without specialized infrastructure investments. Market implications include expanded addressable markets for ASR applications, reduced total cost of ownership for voice-enabled products, and increased competition in edge AI solutions. The trend aligns with growing demand for privacy-preserving AI and on-premises deployment options across industries. Cloud dependency reduction momentum. Organizations increasingly prioritize reducing cloud dependencies for AI workloads due to cost, latency, and privacy concerns. CPU-only ASR capabilities accelerate this trend by enabling high-quality speech recognition without cloud connectivity requirements. This shift impacts cloud service providers who must compete on value beyond basic processing capabilities. The development strengthens the business case for edge computing platforms and hybrid deployment architectures that balance cloud scalability with local processing benefits. Hardware optimization focus intensification. The research highlights growing emphasis on optimizing AI models for specific hardware constraints rather than assuming unlimited computational resources. This approach influences hardware design priorities, with CPU manufacturers likely to enhance AI-specific instruction sets and memory architectures. Software frameworks will increasingly incorporate hardware-aware optimization techniques, while model development practices will prioritize efficiency alongside accuracy. The trend creates opportunities for specialized optimization tools and consulting services focused on deployment efficiency.
What should developers and operators do with this information?
Evaluate current ASR deployments for CPU-only migration opportunities when GPU costs exceed 30% of infrastructure budget. Implement proof-of-concept testing within 2 to 4 weeks using representative audio samples and target hardware configurations. Deploy gradual rollout, starting with non-critical applications to validate performance before migrating production workloads. Establish performance monitoring baselines and automated rollback procedures before transitioning mission-critical voice applications to CPU-only processing.
Thank you for listening to LeadAI.dev. Stay tuned for our next daily updates in this rapidly emerging market.